We are introducing a tremendous new family called Vertex 2, and there's a lot of innovation in there. For one of the most critical ones is a technology called digital impedance matching technology. In our terminology, we call it Xcite, Xilinx impedance control technology. And it really allows you to match the impedance of the output signal and avoid the use of matching resistors, which are always very difficult to bring into our chips.
Just like the slide rule, termination resistors, as we know them, are about to vanish. They're quite simply getting in the way of cutting-edge products. Xilinx's adaptive on-chip termination banishes external resistors to extinction, making PCBs less expensive, easier to design, more reliable, and absolutely necessary for high-speed designs. High-performance systems are in the hundreds of megahertz. Designers can't ignore impedance matching between the IOs and the PCB traces. They need to learn new techniques for signal termination. They need more resistors. 1,500 plus packaged pins need more routing. Alternatives to termination resistors is critical. Fortunately, designers no longer have to worry about terminating their high-speed signals. All Xilinx Vertex 2 IOs are equipped with Xcite, digitally controlled impedance technology. Let's see how it works.
The Xilinx Xcite technology eliminates the need for external termination resistors by incorporating adaptive series and parallel termination on the FPGA itself. Xcite matches its impedance to a pair of external resistors chosen by the designer to match the printed circuit board trace impedance, which may be any value from 25 to 100 ohms. Xcite matches this value by selectively enabling or disabling parallel transistors. A coarse impedance adjustment is made during the device startup sequence, accounting for process variation. During device operation, fine adjustments are continually made to ensure that I/O impedance stays matched as temperature and voltage drift. Xcite is implemented in software either by direct HDL instantiation or using the constraints file. Now let's look at some waveforms. Here's an output bus that's operating at 75 megahertz. Without the Xcite capability, many termination resistors are required on the printed circuit board, which generate ringing, reflection, and seriously degrade the signal integrity. This is not a board I would be eager to show my boss. Now let's look at a similar circuit using the Xcite on-chip impedance matching technology. Since Xcite brings termination onto the die itself, impedance is matched over the full length of the signal path, making signals reflection-free. Note the higher signal-to-noise ratio and the symmetrical rise and fall times. So especially for design and systems engineers, Xcite is important because it allows them to maximize design performance, specifically single-ended bandwidth. Xcite also makes their job easier because they don't need to plan the signal termination ahead of time. They can easily change the terminating resistor value to match the printed circuit board trace impedance after the board is done. And it also reduces simulation time. Xcite also makes life much simpler for printed circuit board layout designers. Without the need for hundreds of terminating resistors, there are far fewer points to route on the board, especially since they need to be very close to the I/O pins. And most importantly, engineering managers care about Xcite. Xcite lowers costs by eliminating external resistors, reducing the printed circuit board complexity. And there's a substantial decrease in the engineering effort. Systems using Xcite are much more reliable because there are fewer components and far less susceptible to temperature and voltage variations. Xcite enables faster time to market because it simplifies the job for designers.
Here at VIP Switch, the Vertex 2 family helps us a lot in many ways. We are doing high-speed board design. The real estate was an issue for us. The high capacity of those parts provide us the capability to put everything on one blade. This is our previous technology. You can see around that FPGA all the termination parts that we use for matching impedance. They are taking lots of real estate on our boards. Here's the back side of the boards. You can see all the termination resistors that we have. So with the Vertex 2 family, we don't need any of those termination resistors. You have to less worry about the line impedance at the layout stage. You can change it later. Also, it reduces the number of layers of PCB. You have a more direct path between FPGA, so you can speed up your design.
I/O counts are going up. So are clock speeds. The Vertex 2 FPGAs enable customers to take advantage of the latest high-speed I/O standards without termination resistors. For more information on Xcite, visit the Xilinx website. I think you'll find that Xcite is the next logical evolution of signal integrity. Don't let your next product be a relic. Use Xilinx Xcite.